Hello, everyone, and welcome to today's SANS webcast. Attack and Defend, the dangers of modern distributed applications. My name is Carol, author of SANS. Today's featured speakers are Jason Lamb, SANS Certified Instructor, and Dr. Johannes Ullrich, Faculty Fellow at the SANS Institute. If during the webcast you have any questions for our presenters, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to our presenters.
Thank you, Carol, for the introduction. My name is Johannes Ullrich, and today, thanks for joining us for this webcast. First of all, in this webcast, Jason Lamb and I will talk through a couple of different vulnerabilities that affect modern web applications. Jason Lamb is a SANS senior instructor and co-author of SEC 522, our Defending Web Applications class. That's, of course, somewhat related here to this particular presentation that we have here. Well, Jason is in the business for probably, I don't know, Jason, 15, 20 years or so of security web applications in various ranges, and he now works for a large financial institution, and he's helping them implementing some of these exact web applications that we are talking about here in this presentation. So some of it is sort of picked from real life. My name is Johannes Ullrich, and I'm the Dean of Research for the SANS Technology Institute, our graduate school. I'm also co-teaching SEC 522 with Jason. Now, in recent years, with our Defending Web Application class, of course, we added cloud. That's what people do. People don't necessarily deploy web applications as much in their own sort of on-premise environment, if you still even have something that resembles an on-premise environment. And we found ourselves adding more and more sort of these distributed elements to the class. And what we found is that organizations find it really challenging to deal with authentication, access control in these environments, and also with securing the disparate nature of these applications and some of these sort of third-party components that are being included. So our goal here is to illustrate some of these challenges to you. And well, I always hate to just talk about what can go bad. We'll also talk a little bit about how to defend against some of these attacks that, of course, are caused by these disparate applications. The way we sort of set it up a little bit is that Jason, he'll play the attacker in this talk, and I'll play a little bit more the defensive side. So that's sort of how we split our roles to make it a little bit more exciting. Lots of demos. We just slaughtered the demo god chicken here to make sure that they all work. So cross your fingers, and fairly complex setup that we have here. Just quickly sort of walking over our agenda here for today. So we have sort of three different scenarios that we want to walk through here in this talk, and like I said, we'll split it a little bit between me and Jason as we go over it. And well, Jason, why don't you just walk us a little bit through this neat little application that we set up here to demonstrate the problems.
Sure thing, Johannes. Hi, everyone, and thank you, Johannes, for your introduction earlier. And let's talk about our environment today. As you mentioned, we have three different scenarios that we're going to cover today, and that surrounds around this particular application. This application that we're seeing on screen is a modern application, just like anything else that you would encounter on a day-to-day basis. So the application basically starts off with sort of a static file storage. If you think about, the websites that you go to, a lot of times you go and download some HTML code, some images, and so on, and then there are JavaScripts, right? So there are tons of JavaScripts that you download, so that it comes to your browser with a bunch of code that you can execute, and it is those code that interact with the rest of the web application, meaning all the business logic are really just APIs, towards some cloud services and so And you've also got, so those logic that are running inside your browser actually interact with, as I said, API. And these API oftentimes, resides in cloud environment. And a lot of times they're not even in your server, right? Like these are serverless type of implementation. I'm not talking about function as a service, but for example, if you need authentication, you would go to like Cognito service within AWS and so on, and use that service, right? That's serverless. With that, you would also have, IAM component. At the back end, we have, in this diagram, we have like ticket lookup with customer API. Those are the back end that are actually servicing the client. So your browser actually talk through the API gateway to these back end, actual service, and then returning data so that you assemble that output within your browser space. So what you're looking at is actually the output of scripts running in your browser. So that's a high level of what we're seeing here in this diagram. Johannes, why don't you give us a little bit of illustration about how the web app actually works?
Yeah, so we kept it simple here. We want to focus on all the different components that we have. So we have a very simple front end here. We are first authenticating to our application. For authentication, we're using a service called Keycloak. Keycloak is an open source component that you can use as an authentication service, has all the features that you sort of would expect from a service like this. Now, one thing I want to point out is we built this application here from, of course, a number of different open source components. What we're going to talk about are not vulnerability in these components. We'll talk about architecture issues. So everything we're talking about here, no matter what you're using for your authentication service or your application gateway, your API gateway, all of this applies whether or not you're using the AWS version of it, the Azure version of it, or some open source components as we are showing here. So I'm logging in with my super secure password. And now once I'm logged in, and let me just not remember my password here. Once I'm logged in, now I can do sort of little ticket lookups. So that's essentially what the application does and how it works. In order to authenticate, we do go to Keycloak. For our API gateway, we use Kong, another open source component here that we borrowed, and we basically created a very simple API that responds to these ticket requests. And let me just show you a little bit sort of what's happening here behind the curtain, essentially. And of course, we do have our developer toolbar here in our browser that we can use here to help us. If I'm clicking on the network selection here, let me just update the ticket a little bit. You see how this particular request is going back to our API. This API/ticket, not sure if you see this, we'll soon make this a little bit larger. But that's the API we call here. There's a pre-flight request that you see first. That's really just the browser essentially getting permission to send this cross-origin request. We are using sort of standard cross-origin techniques here for this application. So now let me just look at this a little bit more detail here. So I can actually copy that entire request as curl. And with that, I can then go back to our terminal here. And this makes it a little bit more visible, kind of what's going on here, what we are sending back. Now, Jason, anything you want me to do with this as evil attacker?
Yeah, that definitely is a good intro to this. Yeah, Johannes, I think it would be a good idea to show some of the slides and so that we can talk through what we're going to do. And I'm going to come with my first attack to you. So there are 3 cases here. Yeah, if we can go back to the slides, let's talk about.
Okay.
Yep. So
Attacker, evil attacker, tell me how you're going to attack my beautiful application.
yeah, definitely. Great. So earlier, I think you already mentioned about the developer tools, which is a really great, debugger, to show everyone how the web application actually works. So earlier I talked about the JavaScript and so on, but if I don't show you inside the browser, it's kind of hard to understand it. But once you actually break things open, like the analogy that I use is always, hey, you pop open the hood of the car and you can see inside the engine bay. That's what it allows you to do. And once you break it open, there are a lot of intricate details there that shows you how it works and let the attackers like me to attack you a lot better. So it gives you a lot of insight. Next slide, please. Now, what we can talk about here is, as Johannes showed you the developer tools earlier, it tells you exactly what request you're sending to the web application server, right? In this case, in our web application server is really an API, gateway, and so on. But the point really is, if you break it open with developer tools, it will show you all the data that you're sending to it. What is common with all the requests that you're going to send to your web application these days is going to be, your GET or POST request, which is the HTTP protocol, what URL you go to, which also, indicate the host name, and you also these days with the modern web application architecture, you also have an authorization token, particularly if you're using the OAuth authentication scheme or authorization scheme. So what that means is that that is your identity, and that's your, essentially becomes your password to actually, authenticate yourself towards the web application. And yep, we can continue to the next slide, please. Now, what we can do under that circumstances, right? Like, so the web application, the backend, the API gateway recognizes, they don't care really who you are, right? As long as you show up with a request and, it has the right authorization header, then it will say, yeah, that I recognize that token because I issued that token earlier. That's, Jason or Johannes, coming to me. That's good. And that's basically how it works, how the web application actually works. Now, this particular instance, the developer here, probably Johannes developed this one. He may have made certain mistakes, right? And later on we'll validate whether he made mistakes. But mark my word, right? If the developers are not exactly careful about, for example, setting up the cloud environment and so on, right? Like your right-hand side, all those inside components, sort of your microservice and so on. And by the way, we show two here, like in organizations like Netflix and so on, there are thousands, right? And each of them would be set up slightly differently, or could be set up slightly differently, particularly if you're deploying it in cloud, right? Like I do teach other cloud courses. I certainly understand that, a cloud is really a configuration file, right? If you think about it. So when you deploy it, when you do not actually get the right configuration, those services could be on the internet. And, that gets things really interesting. So let's talk, with that theory, then, the user can go and directly poke at those, APIs and so on at the back end. And let's demonstrate that a little bit. Let's get into our environment earlier, and we'll show you how that all works together. So, earlier we already have the dev tool, we show you all that stuff, and Johannes already, is nice enough to line up the curl command here. So basically that's the request that we're about to send, right? And, you can see, I'll highlight a couple of things here. At the very top, you see the port 8443, going to ticket API ticket 1231. That's what we're sending, to the web server, to the web API gateway. And don't forget about the authorization header. And then all the other stuff here are just headers, right? So we'll send it. And yep.
Okay, I just sent it.
Yep, that basically what we're doing is that we solicit a respond from the API gateway. And the API gateway basically send it over, forward it over to the backend microservice, and that is our response. And how do I know all that API gateway is actually in place? Look there where the cursor is. It says there xcong upstream, proxy latency, and so on, and beer Kong 204, right? So those indicate to me that, oh yeah, the request actually passed through Kong. Kong actually was at work to bring that data back to me. So that's the environment that we have here. Now, that's supposedly, if I'm the attacker, I want to profile the application. That's what I've just done. Now, what do I need to do next? The scenario that I talked about earlier is that, hey, maybe we'll find that the developer mess up in certain places and expose certain things on the internet. Let's talk about that, right? So first of all, how do we find other potential hosts? Why don't we get back into browser and talk about that, right? Some of the other methodology that we use here often enough, from an attacker standpoint, would be go and port scan. Everybody knows how to do that, right? Like you may be able to scan the same subnet, particularly if you're running on-prem applications, hosting, then you scan, the same subnet. You may find other ports that have web applications on it. That would be part of it. And then the other side of it also is, certificate transparency is a huge, gold mine for attackers. What that means is that when you go and register certificate, TLS, SSL certificates, the CA or the certificate authority, when they issue a cert to you, they are supposed to put it in a log that everybody can access. And companies like Google and so on, they actually go and download the logs so that they make it searchable for you. In this case, we'll search, sec522.com because we own that domain. And basically what Google is telling you is that, oh yeah, hey, these are the names that are associated with your domain, right? Like these are all the search record that I have. And particularly, if you go there and scroll down, look there, right? Within this domain, look at how many host names there are. All these host names could be my attack target, right? So if these may not even be normally exposed to the internet, but maybe they are, right? These are all the names that are being used by this organization. So I'll poke at it, each one of them from the internet and see if they are open. That's what we're talking about for finding the targets. Now, if we happen to find a target, right, like, for simulation purpose, we'll just say that instead of a different host or anything like that, instead of 8443, we'll just say, hey, the real application backend actually sit over at port 443. But you understand that it could be elsewhere. So if we can go back and let's see what we can do to that. If we can change the port to the 443, again, 8443 is a proxy, so it's the Kong, and then the 443 is a real service. Now, what you're going to find is that, once we hit enter here, you find that the service, hey, the answer is the same. Message, we'll get to it whenever we're ready, whenever we're done napping and grooming. Johannes is a cat lover, by the way, cat and dog lover. That's why everything is cat and dog themed. Notice here, one thing about it is that you do not see anything about Kong anymore. So what we have just done is that we have bypassed Kong at this point. So no more API gateway. An API gateway is going to be important from a security standpoint because a lot of security stuff are being injected inside the API gateway. I'll let Johannes talk about in his application what he has layered, what sort of controls he has layered within that web application web API gateway. Johannes, you want to walk us through?
So from a security point of view or defender point of view, the attacker is still authenticating here. So we're not bypassing authentication necessarily, at least not in our application. You see how the bearer token is still being passed along and is actually required here. But there are a couple other things that you may have implemented here in addition to authentication. Let me just go to the admin interface for Kong. Konga, that's the Kong admin, so it gives us a little bit graphical web-based admin interface here for our API gateway. And there are a number of different plugins that I may enable. For example, rate limiting. And let me just enable this here. But there are other plugins that I may find helpful. I could do authentication here. So in this case, if I do authentication just with the API gateway, then bypassing the API gateway would give me unauthenticated access to the API. But in addition to that, there are a couple other security controls here, IP restrictions, for example, bot detection, which is fairly straightforward here in this particular example. But of course, there are other things that I can sort of add, other plugins. These are just the ones that are sort of in Kong by default. Other API gateways have other plugins, other controls that you may want to apply. So I just enabled the rate limiting. Let's see how this works, the rate limiting. I set up a fairly strict rate limiting policy here. To see the effect relatively easily. So let me go back to a request that's going to port 843 with the API gateway. So when I'm sending this now, you already noticed that I do get these rate limiting headers that would inform me about what the rate limit is. So as a good user, I can stay within those limits. And now let me just try to quickly sort of resend some of these requests. You may see it sort of scrolling a little bit widely here. I'm just trying to trigger the rate limit, and here I do have the rate limit. I'm now getting a 429 status code back. That's commonly sort of the standard if you trigger the rate limit. As a responsible user of an API, I would now, of course, back off often send requests slower. But well, I know Jason. Jason, this is like a great API where he gets the latest deals on where to buy his ammunition or so. Then he may want to send requests as quickly as possible to outrun all of his neighbors. So he may find directly the 8443 access here. So let me just go back to 443. No Kong involved anymore. So now I'm able to send these requests as quickly as possible. And again, GoToTraining may not quite keep up with the scrolling here as I'm sending all of these requests. But notice I'm still able to send these requests as fast as I would like to. So that would basically bypass these defenses that are enforced by my API gateway. And you say, okay, developer Johannes, now why don't you do this in your application? Number one, I'm a developer. Developers are nice people. They don't think about all of these attacks. And second, it's additional code that you have to write. If you know how I code, the less code I write, the less bugs. So the last thing you want me to do is write more code if you can do the same in your API gateway. So let me just go back here and turn off that rate limit so it doesn't hurt our tests later, because like I said, I implemented rather severely to show off what it can do. But anyway, so no big deal. I just make sure that my application, my ticket lookup API here can't get reached directly. So how am I going to do this? Back, when it was all nice and on-prem, behind my perimeter, I had my firewalls and all of this nice stuff set up, and life was good. But then these sysadmins came along, and management said cloud, 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 and I said, yeah, great. So before I knew what was happening, all the applications that I created for on-premise were sort of shift and lift to the cloud. The data center was shut down, and one day I walked outside the office and I saw like a big pile of servers in the dumpster. So now, of course, I need to explain to my applications that while they're accessible from the internet now, they're not supposed to allow access from a random IP address from random sources. Okay, so no, good old firewalls, they still work in the cloud. I can filter by IP addresses. You can, but that's not necessarily what you would like to do. IP addresses, they change, in particular in the cloud with dynamic IP addresses. So what you do instead is you set up a private endpoint. In your cloud configuration, you tell this particular web service that it's only accessible from this source VPC. And by setting up these private endpoints, you're able to restrict who is able to access it. So with this, you get kind of a firewall plus plus. Yeah? It's not just IP addresses, it actually identifies the origin of these requests. Here in this example, for example, limited access to a particular S3 bucket in AWS to only allow access from this VPC, and that basically protects us in this case. You still need credentials, so this is not instead of credentials. This is in addition to credentials. You need to actually originate your requests from the correct source. And in some ways, that's like better than what we could do by just filtering with IP addresses. So pretty neat. Yeah? I'm all proud of myself, Jason. So I finally figured out the cloud, and I hear this, infrastructure as code. As a developer, of course, I love it. Finally, I can lay off all these sysadmins that never knew what they were doing, and as a developer, I can do it all myself. But what's your next move, Jason?
Sure thing. Yeah. Hey, Johannes, that's not a bad deal to defend against the attack that I threw at you. What about the authentication, authorization header, right? Like the stuff that is, we sent earlier, it was a really big chunk of text, right? So what it comes down to these days in modern-based web applications, we use a lot of authentication authorization by OAuth, right? That's a really complex standard. And what that also means is that, hey, you can interoperate with multiple different parties. And by the way, you go to the website, right? You see that there is a button saying, hey, you can do social login, right? Like you can use your Facebook identity to log into this website and so on. That's OAuth at play. And that's only one use case of OAuth. There are many different use cases. And one really, signature-based, attribute of OAuth is that, there is the token, and that token these days, we injected extra components within that token. So the token in the olden days, years ago, Johannes mentioned that I've been, in the field for 15, 20 years. Yes, I feel old. But when we started, right, like the web applications are just a cookie. You generate a random string, and that's it, right? Like that's your cookie, that's your authorization, that's good. Nowadays, that token is not just randomly generated. That token, if you care to look inside that token, it has a lot of details. And yeah, I challenge you, you can actually go to your favorite application. If they're using OAuth, take a look at that token carefully. And what I'm talking about specifically is that that token nowadays is actually written in a format called a JWT, JWT, JSON Web Token. And that token has a lot of different meanings. Next slide, please. So, we're going to show you very quickly. And as I talk about, right, like that token, you can break it down. And there are a lot of publicly available tools that you can actually use to decipher or decode your token so that you know exactly what's inside it. So there's no hiding and whatsoever, okay? Next slide, please. Now, before I show you all that stuff, let's talk through, the JWT and so on. Within JWT, there are a lot of details. And JWT is really meant, right? Like whoever is going to come to your web application is going to hold this JWT information that were issued by the identity provider. Well, in this case, it could be like a Google, it could be like a Facebook, somebody like that. The Facebook, the Google actually sign off to say, yep, this is Jason. If you see this with my signature, yeah, you can trust it. And then JSON in turn take the information, take that authorization token to the service that JSON is going to leverage or consume, and tell the service, hi, hey, see this piece of information, Google said I'm good. You should let me use your service. That's how it goes. And then within that JWT job token, there is these type of information that you see on screen. For example, IAT expiration. Those are when the time of when the token was actually or is actually valid. And then you also have the AUD, which is the recipient. Who is this token for, right? Like, because you may just craft it for one particular service, but the other services should not take this token. And then the scope of it, hey, what can this token grant the user access to? That's really what it means. And JOT, also usually work with another standard called OIDC, OpenID Connect, which actually stipulates the exact format, the field names, and so on. So that's really our scenario here. And next slide, please. What can we do with that information? As I said, it's a claim, right? So a claim means that, if I'm the user, I'm just taking that piece of information and send it over to the service, and the service is supposed to recognize who I am based on that claim. And it will let me access any of the service. Johannes and I were just talking about, hey, what if some of your backend is exposed? That would be really bad, right? Like, then I can get one of the token that the application sent me. I can play it directly to the backend service, and the backend service will say, oh, who are you? Oh, yeah. The IDP, the identity provider, actually signed off on this. You must be good. I'll let you use it. That's sort of what we're going to talk about here. Why don't we flip over to the demo and we'll show you how these things all tie in together. Yep. So first of all, we will copy the authorization token that we saw earlier. This all ties back inside this, right? Like, this is all live, real demo. So this was what Kong sent me earlier, right? So Kong said, hey, you type in your username, password, here is your authorization token. So again, we're not hacking the Kong and so on. I don't know that I can even get through the Kong, but hey, I'm not attacking that component that I know is good. What I'm going to do is go to this URL, .it. This is by a company of Okta or Auth0. Okta bought Auth0 recently. And this website has very, very good feature. It knows how to decode your authorization token, the job token. So let's paste the token that we got from Kong here, please, Johannes. So we're pasting that piece of data that we copied from Kong, and voila, on the right-hand side, what you're gonna see, basically the job token can be easily broken down. And you can see the color coding correspond from the left to the right. The first portion of the token basically is a header. Talk about what this piece of information is about. Well, this is a job token. We all know that. And then it talks about later on, there is a signature portion, what algorithm you're using. There are many hash algorithms to actually sign this piece of information, because there is a signature. So the signature is important, as I said. So Kong here, our IDP, is going to issue me this token. Hey, if I'm not careful, or I'm the attacker, you know what I'm going to do, right? I am going to alter the content, and the content is super important. And later on we'll walk through that. But if I'm able to change any of that content, basically I can grant myself a lot of additional permission, and I win the game. So in order to not allow me to do that, applications generally have a signature, or IDP generally sign the message, so I can't alter it. If I alter it, then the service would not take it and allow me to walk through that. So over here, what we can see within the content in the purple section, specifically of interest to us is, I talk about some of the audience, I talk about some of the timestamp at the top, audience, the URL that we're sending to. This is a bearer token, which is an authorization token. And then most specifically, I would like to turn your attention to the bottom part, which is like the rows. So here, basically the IDP is saying, hi, Jason, you can do these all, you can do these particular functions, actions. And those are important because then I get this token, I throw it in here at jot.io, and I know what I can do. So these are really like a gold mine to me. And that basically is important, for what we're going to do later on. Now, if we can go back to the curl command, understanding what the jot token actually does, then we can go back and, maybe one thing that I want to do here, I don't exactly know which, what this particular API, what it can allow me to do. Right? Earlier, I saw that I can do, take over the world and a few other actions, but I don't know exactly how to call, where to call. Why don't we take that, into just the API? Let's call the API, do a handshake, and see if this API will give me a little bit more insight about what its capabilities are. Let's take a look at it. Let's go and set it. Ask the API, hey, what are you? Like, what do you have? This API actually gives me quite a bit of insight. It tells me that if I call ticket, it's gonna, show me the ticket, which we used earlier, but that's not exactly interesting. This one also have COVID formula, right? Like, hey, the vaccine formula, that's pretty cool. That's just what all the hackers, the nation state are hacking for right now, right? Like, how do we make that vaccine? That's useful info. And then the last one is take over the world, right? It's even better. Well, the kitten's plan to take over the world, the cat are always evil, right? So that's what it is. So let's go and trigger some of these actions. Why don't we start off with the COVID formula? Again, what we need to do is send that authorization token. Without the authorization token, nothing works. And we're not hacking that portion right now, right? There's nothing to hack. Right now is a claim. It allows me a lot of access, and you saw that earlier, right? So I'm just going to hit that, and look here. It actually rendered. So now that I know the location, I have the authorization, it lets me go through. And at the bottom is probably, I think this is the Pfizer formula or something like that. That's awesome, right? We might be able to make some vaccine ourselves. What about the other one? Take over the world. Hey, Johannes, can you help us, just take over the world? How do we take over the world? Again, same thing, right? Just a different function, but just to illustrate to you that if the token tells you that you can do it and you know exactly where to hit, you will get the action rendered by the web service. So yeah, that's that, right? Like, hey, that's that's an evil cat's plan to take over the world here. So with that, hey, I've done a lot. Hey, Johannes, what are you gonna do to fix this one? Because hey, I think you're exposing yourself there, right? So what do you do?
Yeah, so first of all, if anybody has any questions, please use the question feature. It's nice if you can collect some questions throughout the presentation. That'll give us a little bit of smoother transition to the questions, and also makes it easier for you, then you don't forget the questions. But anyway, so who better to tell you about JSON Web Tokens than Jason himself? So he told us everything that can go wrong here. Let me talk a little bit about how to defend against some of these issues. So one problem here was that the JSON Web Token did include too much information, really. Information we don't necessarily want our attacker to know. This is a little bit the intent almost of these tokens. We didn't have that problem so much in traditional web applications because all the user had was the session token, and that session token was really, if it was done right, just a random number, nothing really in it. Now, another important concept here is, as Jason pointed out, JWTs, they're digitally signed, so I cannot alter them, but they're not encrypted. They're in the clear. The information is in the clear. It's just the integrity is protected, not the confidentiality. So anyway, how do we go back to something that resembles more what we used to have in our traditional applications? And one way how you can do this is a phantom token. Essentially, what you're doing here is you're using two different tokens in order to authenticate to the API gateway. We're using a different token than the one that's being used to authenticate to your APIs. And the way this is set up is that I'm going to log in to my service. Again, of course, this is controlled by our identity service here, and I'm being handed one of these phantom tokens. When I'm coming back to the API gateway, it's now up to the API gateway to connect to the identity service, and it will return, the identity service will return essentially the original token, so the full token with all the juicy details that are associated with this phantom token. Then the API gateway basically swaps phantom token for the real token, and then this token is then being passed along with the request. So all the details are hidden from the user, and the user no longer has any insight into sort of the inner workings of our application. Now, one problem here is that, actually, let me go back here 1 second. One problem is whenever I'm connecting to my API gateway, there is this round trip that happens between the gateway and the service. And that's not very efficient. I'm already always complaining that, you know, once you're doing all these modern web apps, a simple stupid API request becomes like 3, 4, 5 different API requests as it sort of moves its way through the chain here. So we want to make it a little bit more efficient. And this is where split tokens come in. So again, I'm logging in to the identity management service, and it hands me now a split token. Now, this is typically just the signature of the token, not the actual content of the token. And when I'm now connecting to the API gateway will request this token, but will cache it. And it will use the signature of the token as an index. So that way, when I'm coming back with that particular split token, with that signature, the API gateway can look at its cache. Do I already have that token? Can look it up and no longer has to consult the identity management service. So that way, you know, I am able to get access to all of the APIs without having to consult the identity management service for every single stupid request that I'm sending. So this just speeds things up and takes some of the pressure off the identity management service. So with that, Jason, now I'm secure. Nothing else you're going to do, because you no longer get my tokens, and pretty much anything behind the API gateway is properly secured. So it almost feels nice and cozy, like my on-premise world. Yeah? We only spent like a few $1 million probably in AWS charges because of all these recursive lambdas I set up for that. But what are you going to do now? What are you going to do next?
Good job, Johannes. It's a little bit frustrating because, you know, every single path that I found, you fixed. So, I got to think a little harder. Why don't we turn it over? Why don't we turn over our attention? Hey, you know, these OAuth token and stuff like that are fine, but there are other things that, you know, are quite vulnerable as well. These days, all applications, as you said earlier, right? Like developers don't like to write more and more code, right? Like they want to focus more on quicker development, you know, focus more on the business logic, you know, type of coding rather than building all these infrastructure and stuff like that. In a lot of ways, nowadays, when you build an application, it's like Lego, right? Like you assemble different components from different libraries out on the internet, and then you build your application that way. So it is in a big way, you know, hey, every application uses like jQuery, but that's only one tip of the iceberg. You know, there are tons and tons and tons of other resources that you're likely going to call in your web application. And those, you know, if I can't hack your site, Johannes, maybe you use some other libraries out there, right? You have components out there on the internet that are more vulnerable, like the hosting, either the hosting or the script itself is not as vulnerable, or not as secure well, and more vulnerable, so that I can take advantage of that. And I don't need to hack you. I just need to hack your dependency. So that's what I'm going to try here, right? And a lot of times that actually helps the attacker quite a bit. Next slide, please. Yeah, so the question is, how do you find some of these third-party vulnerability, third-party components, and find out whether they're vulnerable or not? Well, again, the developer tools gives you a lot of details. Every single load, you got to see where it is coming from, and sometimes, as we show earlier, it is the location of where the browser is going to pick up that script and so on. And just based on the location, you can easily go to that location and say, hey, are you vulnerable, right? So the attacker has a very, very easy job to do here, right? Like you don't have to look very hard. You just need to open up the debugger in the browser, and it gives you all the insight. Next slide, please. So what we're going to do is we're going to pivot over to showing you how these things are done, what we specifically talk about. So within this application here, what we have is we know that if we call certain components within the application, if we can go back to the developer tools to show that, that would be awesome. And I think that would show the, So you can see that there is a jQuery. Almost every website that I know use jQuery, right? Like that's one of the most common, JavaScript framework that are being used these days. Since about 10 years ago, right? So this one is probably our target, and we, let's assume that, where it is hosted, I can actually go and hack it, right? Like in the interest of time, I won't show you how to do infrastructure and those hacks, but we would just go here and assume that I can hack it. And we would replace it with a Evo version that I have written. And hint here, the Evo version is scripts that I mock up based on the original one, and I add a whole bunch of stuff to it. This one actually is a JavaScript keylogger. What it means is that once I load this, once I replace this JavaScript, whoever comes to this website, right, the website that leverages this JavaScript, their browser start running this code, and their keystrokes on the website are sent to my location, the Evo location. That's what this is about to do. And then, so I also have a receiver here, just listening in. Whatever it comes, I will, log all the keystroke, and I know exactly who is doing what, and so on. So let's show off, let's reload this page because we just altered the JavaScript. Now, remember that jQuery, whatever, that's not the original jQuery. This is my code, right? And once we type something there, you can see that on the right-hand side, there are calls out to the keylogger, right? The request to the keylogger, and it's sending, all my keystroke over there. Type in 1, 2, 3. Each keystroke is sent to the Evo location, to the Evo domain, and I'm capturing all that stuff, right? Like you can see the browser is telling you the initiator is that JavaScript, the JavaScript, tell me to call it. So yeah, exactly. Thanks, Johannes, on that. And there, I'm capturing all your keystrokes into a file. That's what it is. And your IP address is locked as well. That's what this attack is about. So if I'm able to if I can't hack you, I'll hack some of your dependencies, some of the libraries that you use on the internet. And if I am successful at attacking it, this is what's likely going to happen to your site and your user's browser. With that, Johannes, hey, this one, what are you going to do? Like, it sounds like you're still in trouble.
Well, so I'm of course, I'm a control freak. I'm going to host everything myself, but then management says, spend like another 50 cents on bandwidth. Johannes, why don't you spend a few hours trying to fix this? Yes, we want to sometimes host these components on CDNs and the like, basically on networks that we don't control. There is actually an easy trick that browsers have implemented that helps us defend against this. That's sub-resource integrity. We have to tell the browser what we are expecting from these third parties. And we do this by adding a hash. to the script tags. These hashes will be used to guard against an unauthorized change of that particular component. So instead of just having a script tag with a source, we add this integrity attribute. This is now a hash for the particular component that we are requesting. There's also this nice cross-origin property here that allows us to limit what credentials are being sent to this third party, because after all, I don't trust it, so better not send any credentials to it. Let me just show you what this looks like. So we have one version of our index page, and just go to this that uses this. So SRI here. Let me just find it. So here's our script tag now. Same script tag as before, but we do have this integrity attribute with a script, with a hash for the correct script. If I'm loading this page now, so instead of index.php, I load index.sri.php. You see we get an error here. It does not load the script because it does not actually have the correct hash when it calculated the hash back. So the content was altered. That's why the script doesn't load. If you wonder how to calculate those hashes, there's actually a really easy website to do this with, srihash.org. Now, in order for this site to work, the script has to be publicly accessible. So I can load it here using this page. Let's try jQuery here as an example. Let me just pick this slim minified version here, copy the link address, go back to srihash.org, paste it in. And I can pick the hashing algorithm. Everybody seems to be picking SHA-384, and it's certainly plenty good enough for this purpose here. And it'll come back with the script tag that I can now copy paste into my code. And as a developer, I love copy paste. So that's how I write most of my code. If it's not Stack Overflow, then it's srihash.org, what I'm using. So, Jason, hey, I got here. Yes, you can defend against these dependencies or modification of these dependencies by adding that SRI hash, that integrity attribute, and that's supported by all current browsers. So anyway, Jason, anything we learned here today? You want to go over the last final spots here?
Well, I think we've covered quite a bit of different things. Yeah, hey, good job defending yourself. Yeah, I think there are a few things that we've definitely learned, right? Like even I learned a few things, out of the defensive side. Yeah, I think a lot of the web applications that we use these days are, seemingly very good looking, very slick, very responsive. But then if you open up the hood, look inside, they're not exactly well written, right? And it's not because the developer don't want to do a good job. All developers that I met, are diligent. They try to do their best, but they're also not trained in the security side. So I think what it comes down to is learning about these security patterns, particularly with the cloud areas. There is a lot that you can learn from all of that, right? How you actually leverage, platform as a service, components securely. That's going to be a, really important thing. And then the other thing is about OAuth, right? The OAuth, I call it the OAuth dance, because you pass token around and you got to go back and refresh token, get exchange, back into bearer token. That's, a lot of things could go wrong there. Like those are very complex patterns. So learn about those patterns is really important. And then, once you learn what works for your organization, get it into, guidelines so that developers can follow. Those would be, some of the recommendations that I can make here. And Johannes, did I miss anything, or from a development angle, what else would you do here?
I think that's pretty much it. And like I said, it's not a simple shift and lift for your applications, particularly these complex applications. Think it through. Think through access control to the components as you are moving sort of to this distributed architecture. Now, let me just look at some of the questions here that we got. We still got a few minutes here for questions. So if you have any questions, please use the question tool here. And I'll pick a couple that we already got here to get us started. But let me answer the first one. I'll give the second one to Jason here. But both are actually from Matthew, and I think there are good points to reiterate here. We made the points already a little bit, but I think it's very important. So the first one is, can the attacker change the auth token in JWT.io? Not really, because the token is digitally signed. Yes, JWT.io actually has a feature. If you have the secret key, it will recalculate that signature for you. But just like any cryptographic keys, you have to secure those secret keys used to sign those JWT tokens. And the assumption here is the attacker doesn't have access to them. If the attacker has access to them, then you have other problems that we didn't really go over here. And that's sort of a more classic, hey, you leaked your secrets problem. Now, the second question here, also from Matthew, and I think that's one for you, Jason, here. Can you talk a little bit about replaying, just replaying a token? Can I use the same token twice?
Yeah, so I'm happy to answer that one. So in the OAuth, well, token in general, there are some tokens that can be replayed, but this one, and some token that cannot be replayed. But this one in OAuth, right, like the OAuth scheme itself, definitely can be replayed. There is no, it's just a claim. That's what it is, right? Like, for the duration, you can keep playing it. This is a little bit like SAML would be very similar, right? Like as an attestation is a claim that says, hi, the IDP signed their name to say, yep, this is Jason. For this duration, Jason can access this portion of data. And yes, you can play it multiple times. And up until that timestamp expire, I can still access things. Which is, by the way, very good question, which is also why a lot of sites right now are crying because they cannot lock the user out. That's also a problem as well. So good question. Yes, replay is definitely possible.
And it's really sort of like your classic session ID in that sense. Or if I get your session ID, if I steal it somehow, if I guess it somehow, yes, I'm able to impersonate you. Similar if you're obtaining that bearer token, for the most part, within the restriction that I set up. And in some ways, it makes me better here because you can set up some of these restrictions with these tokens. Within the restriction of token, I'm able to impersonate you.
Yeah, and one other thing to keep in mind there is that, nowadays we're talking about modern distributed application. So part of the component could be Azure, the other part is in GCP. They all need to interoperate. These tokens are meant to be played here, played there, and they all recognizes it based on the same digital signature, right? Like, okay, the signature checks out, I'm good with it. That's how it goes.
Now, back to the SRI, the integrity hashes, Jason. Any idea how to deal with third parties that send customized scripts? Does it still apply, or do I just have to trust the third party in this case? So the application here would be if I, for example, include from a third party some user tracking script or something like this that is modified for each request in order to track these users. Any option there that I have, or really just it's back to trusting the vendor?
Well, there are a few things there, right? So so SRI definitely is the intention of SRI is to lock it down to a particular signature, so you can only run one version. So earlier, what Johannes was showing is that we're picking on a particular version of jQuery to run, right? And it wouldn't run. So what you cannot do is do jQuery-latest. That would not do, with the hash, because then the hash would change, periodically. So there are other standards that could potentially work in that particular use case there, right? For example, you have content security policy, CSP. You can look into that. That would actually help you identify, not just particularly the hash, right? But essentially you run particular nouns into the script so that it will run. Like, you can actually tell a specific, third party to run your script as well. You can also specify, yep, hey, if the origin comes from jQuery.com, yeah, I'll run all their scripts. That is possible as well. So you can specify those things too.
Yeah, and we have time for one more question here, actually. And that question comes from Christian. It's a good question to sort of close up things because it's a little bit more open-ended question. What if while planning a migration to the cloud, your cloud provider suggests reference architecture for your existing on-premise application? How can I be sure that breaking my monolithic application will remain secure after turning into a distributed application and repackaging it in containers? Any good advice here in one sentence or less? How to move an application to
very high level here, right? Like, as I said, I do teach another course that is, about cloud security. So it comes down to a few things, right? Number one, look at your architecture. Understand what you're trying to do, where the components are, how do you actually tie it all together? Then the next portion of it is, how do you actually structure your configuration and also the IAM within the cloud? There are a lot of things that you're still doing in the cloud, and there are things that you don't do, right? The analogy is like moving from a house into an apartment. Well, now you don't manage your own gym, right? Like, the apartment manages your gym. So there are certain things that you don't need to do anymore, but you got to figure out those things. And then, as I said, understand what you're doing is really half the battle, right? Then you can overlay it with some of these controls that Johannes was talking about earlier. Then, generally that would be quite successful. What it comes down to, cloud, configuration, IAM, you fix those, yeah, you're pretty much, reasonably on a stable foundation. Yep.
Yeah, thanks, Jason, here, and our contact information is on this slide. Maybe just adding for myself here in response to the question, one technique that you may want to consider is a good threat model as you're moving the application. So to really think through, have you covered all of some of these openings that moving to a distributed application kind of provides here for the attacker. But yeah, thanks everyone for coming, and also thank you, Jason. It was nice to see you here again. And yeah, that's for me.
Carol, thank you.
Yeah, thank you so much, Jason and Johannes, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.